Hi folks, this is Nat, and we are going to be looking today at inverse equations and seeing how there are ways of looking kind of at the same relationship from two different perspectives. So when we refer to this idea of inverse equations, the first thing we want to kind of be aware of is those are equations that mean the same thing. But the word inverse means opposite. So inverse equations are going to take the same relationship and look at it from opposite directions, or maybe you might think about it from different perspectives. Here's an example of what I mean by that. This says Sally is 8 years older than her cousin Molly. Well, there's two ways of looking at this relationship, and they're both true. Sally is 8 years older than her cousin Molly. But the other way we could look at this is that Molly must be 8 years younger than Sally. Those two things mean the same, but I've said them in different ways, and we can represent those with different equations. As we go about doing this, it's kind of nice to, again, keep in mind keywords and numbers and things like that. So Sally is 8 years older than her cousin Molly. It occurs to me that the important relationship here is that Sally is 8 years older. She's older than Molly is. And one way that I can keep myself organized here is actually to make a bar diagram. So I'm going to go ahead and start with one big bar like I usually do. And in this case, I know that Sally is older, so I'm going to make this whole big bar represent Sally's age. And since Molly is younger, we're going to make a smaller bar, a piece of Sally's bar, represent Molly's age. Finally, since I know that the difference between their ages is 8 years, I'm going to put 8 here in this unlabeled bar, and that's going to represent the difference between the two ages. Now it's time to start thinking about how we can actually write this equation. I'm going to go ahead and say Sally's age is going to be S and Molly's age is going to be M, since I don't know either of their ages. They'll both be variables. But I can start thinking about the relationship here. One way I can look at it is that if I take Molly's age and add that 8 to it, it'll be the same as the Sally's age bar. So I could write that as Molly's age plus 8 would equal Sally's age. Alternatively, I could think about the entire bar, this entire bar being Sally's age, and if I took away that 8, now it represents Molly's age, or it matches up with Molly's age. So I can say Sally's age, the big age, minus 8 would equal Molly's age. So again, two ways of looking at that idea. Sally is older than Molly, or Molly is younger than Sally. And here are the two equations that mean the same thing, but look at it from those different perspectives. Those are inverse equations. Here's one more example. There were 7 times as many werewolves as vampires. Again, I'm going to kind of think about that keyword relationship, and I think the idea that there's 7 times as many is an important thing. As I read that, there were 7 times as many werewolves as vampires. My interpretation is that there's a greater number of werewolves. So when I make my bar diagram, I'll be labeling that big bar as the number of werewolves. And since I've already established that 7 times as many is sort of the important relationship here, I'm going to be breaking that bar up into 7 roughly equal chunks. And if they're not perfect, I'm not going to spend a ton of time worrying about it, but I am going to make sure that there's 7 of them and that they're, reasonably even. Now, every one of those chunks is going to represent the number of vampires, because again, there's 7 times as many werewolves as vampires. So here's the number of vampires. I could label every chunk that way as vampires, but I don't really have to. I know that I'm intending them all to be equal. So once again, there's 2 ways of looking at this relationship. I could look first at vampires and say, well, if I wanted to make it so there were as many vampires as there were werewolves, I'd have to take those vampires and multiply it by 7 to be equal to the number of werewolves, because 7 sets of vampires would equal the number of werewolves. On the other hand, if I want to start by looking at it from the werewolves' perspective, I could take that big group of werewolves and split it into 7, like we said in the bar diagram, and that would give us each group equal to the number of vampires. So these, again, are inverse equations. They mean the same thing. They just look at the relationship from 2 separate perspectives. You might already kind of be aware of it, but it's worth noting, since we're specifically dealing with inverse equations here, that inverse operations are really important to this idea. And it's the idea that each operation, addition, subtraction, multiplication, and division, has an opposite operation to it. If we think about addition, the opposite of addition is subtraction. So the inverse operation is subtraction. And vice versa, the opposite of subtraction is addition. On the other hand, the opposite of multiplication is going to be division, and the opposite of division is going to be multiplication. And you can kind of see that in our inverse equations. If we look at this werewolf-vampire equation, set of equations, we can see that in our inverse equations, we're doing the inverse operations. And the same thing is true here in our age comparison equations. In the inverse equations, we're doing the inverse operations. So if you're trying to create an inverse equation, it can be helpful to think about that. Well, if one equation was subtracting 10, probably the inverse equation might have something to do with adding 10. If one equation is, I don't know, multiplying by 100, the inverse equation maybe has something to do with dividing by 100. It's a good place to start. And here are your practice problems. First, I want you to make a bar diagram for each of these relationships, because it really will be helpful to you in figuring out the inverse equation or equations. But then I do want you to write a pair of inverse equations for each relationship. Good luck.